Hello friends, good evening. Today we have another topic to cover and discuss, which is very important in terms of examination point of view, the number system. In my previous classes, I have taught you the theory related to the number system. What is the theory which is starting from the started from the binary number system and the decimal number system. So today we cover how to convert the decimal number system to binary and along with various like octa and hexa. How do we convert them from one to another? So first is number system. Number system, there are two type of number system. One is decimal number system, which is from 0 to 9. Any digit I can take between the 0 to 9 and I can make any numbers, so which is a decimal number system where we have a decimal numbers. Second one, which is a binary number system, which is comprises only the two terms. One is 0 and another one is a 1. 0 or 1, I take only the 0 and 1 system. Third one is octa. Octa comprises 0 to 7 and hexa comprises 0 to 9 and AF. AF include what is A? A means 10, B means 11, C representing the 13, D representing the 13, E representing 14 and F representing 50. So whenever you would get to see any things related to the decimal number system, which is 0 to 9, and binary, which is include 2 digit only, 0 to 1, and octa, which include 0 to 7, and hexa include 0 to 9 and A to F, because other than 0 to 9 we don't have any numbers, so we are representing by A to F, so which is the 6 numbers. So next, if I convert here, if I take you to the conversion before take you to the practical questions, I'll make you understand whenever you convert these terms actually. So what you need to remember: first, when you are converting decimal to binary, any decimal number, when you are converting into the binary, then always divide it by 2, right? The same way, if you're converting decimal to octa, then divide by 8, and decimal to hexa, then divide by 16, as binary means 2 and octa means 8 and hexa means 16. Here, if you are converting just opposite any number to the binary number, then of course you need to multiply it. Suppose if you are converting binary to decimal, then multiply by 2, and octa to decimal, then multiply by 8, and hexa to decimal, then multiply by 16. So these are the common forms, decimal to binary, octa, hexa, and from binary, octa, hexa to decimal. Now if you get to learn only two things, how to convert from binary to decimal and decimal to binary, then you do all the questions related to it. Suppose if I need to convert from octa to binary, then if you convert directly from octa to binary, then it is little bit confusing. So first you convert the octa to decimal, then decimal to binary. It is very easy again. Same way, if you convert to hexa to binary, then first convert hexa to decimal, then binary. Similarly, the binary to octa, first convert the octa binary to the decimal, then octa, then binary to decimal, then hexa. So before converting any things like octa and hexa to the binary, make sure that you are converting it first into the decimal, or vice versa. So directly you cannot go to the binary numbers. So now in a further I make you more clear. Suppose now I take to the question. First, decimal to binary. How to convert any decimal number to the binary number? Before attempting any questions, please make sure you are going with the base. Write always the base, because base is only identify, that means which is that number. Suppose if base is 10, then it is representing the decimal number. If base is 2, then it is representing the binary number. If base is 8, which is representing the octa. If base is 16, which is representing the hexa number. So here decimal to binary, which is 23. 23 is a decimal number because it has a base 10. So now I need to convert it into the binary number. As we gone through the formula, whenever we are converting decimal to binary, then always we need to divide it by the 2. So the dividing 2, as it has mentioned, it is very easy. Keep dividing by 2 and take the remainder sidewards. So if you divide 2 by 13, then 11, 11 to the 22, then same 5 to the 10, one remainder, then 2 to the 4, one remainder, and the last that constant which remain, I take this also. So 1 0 1 1 1, this is the binary number of 23. So if you are writing the binary, then please write the base also, that 10112. So this is the binary number of 23. Now if I need to either recheck it whether I did the correctly or not, or you need to convert the binary to decimal. So that's why I have taken the same number, so that you would get to have more clarity on it. So the binary number I have a 1011111. Now I need to convert it into the decimal. As per the formula, or as per it, here if I need to convert binary to decimal, then I need to multiply it by the 2. So first I need to multiply 1 into 2. That means we take a power from 0. 2 to the power 0, 2 to the power 1, 2, 3, 4. So 1 multiply by 2 to the power 0, again 1 multiply by 2 to the power 1, 2 to the power 2, 2 to the power 3, and 2 to the power 4. Then take the numbers. 2 to the power 0 means 1, multiply by 1, that means the 1. Same 2 into 1, 2. 2 is 2 to the power 2, that means 4 into 1, 4. Here 2 to the power 3, that means the 8. If I multiply any number to the 0, then of course it is 0. Then last one is the 2 to the power 4, that means the 16. So now I need to add up all. 16, 4, 20, 20 or 2, 22, and 1, 23. So 23 is a decimal number. So now if I converted 23 into the binary number, and again the binary number I have converted to the decimal number. So that's how we do convert. So again I'm saying to you, it is again very important converting to the decimal to binary and binary to decimal. If you get to know it thoroughly, you can convert anything, because in a later when you convert to any number to the octa, hexa, whatever is it, then binary to decimal and decimal to binary is again very important. So how to convert decimal to binary? That means by multiplying by 2. And if you binary to decimal, that means the multiply by 2, and binary to decimal by multiplying, and decimal to binary by dividing it. Now next, we take decimal to octa. In a previous class, in a previous slide, we did decimal to binary and binary to decimal. Now we have a decimal to octal number system. So decimal 216 is a decimal number because it has a base 10, so I can recognize it, or else I do have a confusion whether it is a octal number or a decimal, because 216 base 10, so it is a decimal number. So what I need to do is we have a formula, so that means keep dividing it by 8, the same way we did in the previous slide. Divide by 8, 216. If I divided it, then I have a 27 is a remainder, then 3 and 3. So if I take it from bottom to up, 330 base 8. So decimal of 216, the decimal, if I convert 216 into the octal, then 330 is a octal number. Now octal to decimal, if I convert from octal to decimal, the octal, the same number I have taken, 330 base 8, so it is an octal number. So I need to convert it. How do I convert it? By multiplying it. Same I did previous. 0 to 8, 0 to 8 ki power 0, 3 into, then 3 into 8 ki 8 to the power 1, and 3 into 8 to the power 2. So 0, 24, 192, then I add up it. So this is 216 base 10. So that's how I converted octal to decimal, by multiplying by 8, and decimal to octal by dividing by 8. So how to convert octal to decimal to octal and octal to decimal. Now next, here only I cover how to convert binary to octal and octal to binary. As I said you earlier, converting binary to octal is little bit confusing. So as I mentioned in the formula, binary, if I need to convert binary to the octal, so first I need to convert binary to decimal. Then converting decimal to octal is very easy. So that's why first I am converting any binary number. The binary number is 1111. 4 times ones base 2. So it is a binary number. So I need to convert it into the octal. So directly I am not converting into the octal number. First I am converting binary to decimal. Then decimal, it is very easy to convert into the octal number. So binary to decimal, which is very easy. So multiplying by 2 as I did earlier. 1 multiply 2 0 2 की power 0 2 की power 1 2 की power 2 2 की power 3. So I converted it and adapted. So 15 base 10. So it is now I have converted this binary number into the decimal number, which is 15 base 10 15. Now this particular 15 number, which is a decimal in number, I can convert it into the octal very easy by dividing the 8. So the 15 get divided by 8. So I get 1 and 17. 1 is a constant, 7 is a remainder. So I take 1 and 7. 1 7, now it is a octal number. So it is very easy again. The binary number which I converted. So the binary number 1 at 4 times once I get converted into the octal number is a 17. So I hope is it clear. So now octal to binary. Octal to binary, again I need to convert it. Octal number I've been taken the same number, which is a 17. So 17, now if I convert the octal to binary, then again it's a little confusing. So first octal number I convert into the decimal, then decimal I very easily convert into the binary. So this 17 is an octal number which I convert into the decimal first. So how do I convert? By multiplying 7 into 8, 7. 7 into 8, keep 8 to the power 0, and 1 into 8 to the power 1, that means 7 8. So 15 is a decimal number, which I get already did in the by when I converted binary to octal. So this 15 is a decimal number. Now this decimal number I can convert very easily to the binary by dividing by 2 and take up the numbers from bottom to top. So 15 get divided by 2 and take the remainders and constant. So 1 1 1 1 base 2. So this number again, the number from where I started, tuple 1, the binary number. So that's how I convert binary to octal, octal to binary. Now next, which is decimal to hexadecimal and hexadecimal to decimal. So converting any number from decimal to hexadecimal, it is easy unless we are not dealing with the binary. So here the decimal number is 1748, the 10 base. So what I need to do? Very easy, divided by 16. So 1748 get divided by the 16. So how much I get? 109. Then 109 again get divided by 16 with then got divided, and 16 is a remainder. So I take the constant along with all the remainders. So which is 6. Again the procedure remains same. The process remains same from bottom to top. 6, 13 and 4. Now I need to take care of the 13. Here 13, we have a 2-digit number, but what I need to do whenever I take it further, that means I consider the whole number as a 1. So here I written 6 13 4, the base 16. So this is the octal, this is the hexadecimal number of the 1748. Here as we mentioned in the earlier, the A to F, which is the number. So 13 is representing here like A means 10, B means 11, C means 12, and D means 13, and keep going up till F or the 15. So D means 13. So sometimes they ask question related to this also. 6D4. So D representing the 13. So this is the hexadecimal number of decimal numbers. So now this number I need to convert again hexadecimal to decimal, as I shared you. That means the multiplying by 16. So here 6, 13 and 4. Keep in mind 13 is a single digit number. So first 4 get multiply by 16 to power 0, that is the 4, and 13 multiply by 16 power 1, 208. 13 itself, that means the whole number, the 6 into 16 to the power 2, which is 1536. So if I get sum of 1536, 208 and 4, which is 1748. So 1748, the base 10, the 1748 is the decimal number when we convert to the 613 hexadecimal. So the same, you can check it whether it is a correct or incorrect. So that's how we convert the hexadecimal to hexadecimal and hexadecimal to decimal. Now the last, which is binary again. Binary to hexadecimal and hexadecimal to binary. As I did in the previous slides, binary to decimal, how do I convert it? First convert the binary into the decimal, then decimal to the hexadecimal, as I did, like decimal to hexadecimal here, as I did. So binary to decimal, the binary number is 6 times 1. 6 times 1. So what I need to do, convert to the binary into the decimal, get multiply it by the 2, keep our 0 to keep going. So 1 into 2 keep our 0, 1, 2, 3, 4, 5. If you take the sum of it, 1, 2, 4, 8, 16 and 32, which is the 63 base 10. So the binary number 4 times 1, if I get convert into the decimal number, then I get 63, the number. Now 63 is a decimal number, then I can convert it into the hexadecimal by dividing it by the 16. Very easy. 16 3 just 64, the 48. So if I take a 15 as a remainder, so 315. So 315 is a hexadecimal number of binary number 4 times 6 times 1. So 15, of course I can write it as a E also. Now I convert it into the hexadecimal to binary. Hexadecimal is the same number. 315 is a hexadecimal. If I get convert into the binary, then multiply by it by the 16. 15 into 16 power 0 and 3 into 16 power 1. So 15 and 48, if we take the sum of, which is 63. So 63 means hexadecimal, that particular hexadecimal number first converted into the decimal number. Now this decimal number I can convert into the binary number. So 63 is a decimal number. 63 get converted into the binary number by dividing the 2 and take the quotient along with the remainders from a bottom to top order. So this is 6 times 1 base 2. So now you can match it from this particular number, binary number, from where we started and where we ended. So this is how we convert it into the hexadecimal to the decimal, and binary to hexadecimal and hexadecimal to binary. That's how I can convert it. Now what we need to take care of it, first we need to take care of it how to convert the decimal number to binary number and binary number to the decimal number. Or you can take the help of you can take help of this particular slide, which make you more clear the conversion. Suppose if you are converting any number like a decimal to binary, so that means the binary you are converting into the binary, then divide by 2. Same if you are converting into the octa, then divide by 8. If you are converting to the hexa, the decimal number, then divide by the 16. If you are converting any number, suppose like a binary, octa or hexa, into the decimal number, then we need to multiply it. Simple. Two things you need to remember: how to convert the decimal to binary and binary to decimal. Suppose if you are converting octa to binary and hexa to binary, or binary to octa or hexa, so first we need to convert it into the decimal number, and converting to the decimal to binary and binary to decimal, it is very easy. So I hope you all been clear to the conversion, how to convert binary to decimal, decimal to binary, and octa, hexa, among them. Because from this particular the chapter, all competitive exams, they will ask questions either related to the theory or related to the conversion. So right along with that, sometimes they would also ask the complementary system. the complementary system of the binary digit, complementary system of a 1 or complementary system of a 2, they would also ask. So that particular things I'll cover in the next class. So thank you.